So, welcome back to All This Math. This is Professor Parker. Please make sure you're subscribed to the All This Math YouTube channel. Make sure you like this video. Make sure you drop a comment down below and make sure you share this video with some other people. Please share the wealth, share the knowledge, share the information. All right. Also, shout out to Virginia State University. Yeah, John Mercer Langston was, I believe, the first president of Virginia State University. John Mercer Langston has a long and storied history. Before that, he was the dean of Howard's Law School. Prior to that, or maybe he was the dean of Howard's Law School after he was president of Virginia State University. One of them two. Forgive me if I messed that up. But at any rate, shout out to this historically black college and university in Petersburg, Virginia, where 85 and 95 split when you're driving down south. All right, so what are we doing today? We're going to find the LCM, least common multiple, of these three numbers. All right, now it's a few different methods that we can use to do this. Right now, we're going to use the prime factorization method. The prime factorization method. Let me make sure my microphone is still on. Okay, cool. All right, yeah, the prime factorization method. All right, so that means we're going to factor each of these three numbers, right? We're going to factor them and break them down into prime numbers that will give you the product of the original numbers we started with. And then we're going to compare those prime factors in order to arrive at the least common multiple of all three of these numbers. All right, so let's get to it. So let's start out with the number 8. Now, I like prime factorization because it's pretty easy to do. All we're doing is just thinking of factors of these numbers. Now, like for 8, for example, all right, the only factor you don't want to use is 1. So, for example, I'm not going to break 8 down into 8 times 1 because that's actually not breaking it down because I still have an 8. 8 times 1 is the same thing, right? So what's going to happen is I'm going to break 8 down into 4 times 2 or 2 times 4, right? And then, so I got 4 times 2. 2 is a prime number, so I can't decompose 2 anymore. 4 is composite, though, meaning 4 has more than 2 factors, right? 4 is composite, so that means I can break 4 down. So I'm about to break this 4 down. So I break the 4 down into 2 times 2. So now I got all prime numbers at the ends of my tree branches. All right, 2, 2, and 2, 2, 2, and 2. So I'm done with 8. All right, I'm done with 8. Then I go. Why don't I pick another? Why don't I pick another color for 42? Let's do 42, and then let's just break 42 down. And then see, this is why it's good to know your multiplication facts from memory and by heart, right? Because I could just pick any 2 factors of 42, right? 42, I could say, all right, what about 7 times 6? I know 42 is equal to 7 times 6. So I'm going to just break it down into 7 and 6. All right, now 7 is a prime number. So we can't decompose that no more. That's done, right? We're done with 7, right? But the 6 is composite. So we can decompose the 6 into 2 times 3, right? 2 times 3. So now 2 and 3 are both prime numbers. So now 42 is done. I got 7, 2, and 3. 7, 2, and 3. All right, prime numbers. Now, let's go to 84. Let's go to 84. So we got 84. Let's break that down. All right, now, I happen to know, again, multiplication facts that make life so much easier in so many different levels of math, right? Just knowing your multiplication facts. Do yourself a favor. If you are watching this video and you don't have the multiplication facts memorized at least up to 12 times 12, do yourself a favor and memorize them ASAP. ASAP. All right. Now, I know that 12 times 7 is 84. So I'm going to break this down into 7 times 12. Why did I put the 7 over here? Because I know I'm going to break the 12 down and I needed more space. And it's a little crowded over there. There ain't nothing mathematical about it. It's all about space considerations. All right, so now the 12, the 7 is prime. 7 is prime, so I ain't messing with the 7 no more, right? That's why I wrote it on this side, because I don't need to break the 7 down. And I don't have to worry about running out of space over here. But the 12 I could break down. The 12 is a composite number. So the 12, we got 4 times 3, or I could have did 6 times 2. It don't matter. It don't matter. The end result is going to be the same. I'm going to have the same prime factors at the end of the day. All right. but the 3 is prime, the 4 is not. So I could break the 4 down. Since the 4 is composite, I break the 4 down into 2 and 2. All right. So I got all prime numbers 7, 2, 2, and 3. For the 42, I got 7, 2, and 3. For the 8, I got 2, 2, and 2. So now this is how we do this, right? Notice how we got the red, the black, and the green, right? Like X-Clan said, the red, the black, and the green, right? Now, this is one way to do this. Now, there's like a table method that I've shown on other videos on this channel, but another way to do this is basically you just go through all your prime factors and you say, okay, under 8, right? What are my factors? 2, right? 2 is one of my factors for 8. How many 2s do I see? How many 2s does 8 have? 8 has 3 2s. 8 has 3 2s, right? Then you ask yourself, how many 2s does 42 have? 42 has 1 2, one of them, right? 42's got one of them. 8 has 3 of them. How many 2s does 84 have? 2 of them. So what's the maximum amount of 2s you see out of those 3 numbers? 8, 42, and 84. 8 has 3 of them. So 42 only has 1 of them. 84 has 2 of them. So because 3 is the maximum amount, that means to find your LCM, you need 3 of them. You need the maximum amount you see. So we're going to need 3 2s. So I'm going to just say for LCM, I'm going to say 2 to the 3rd power, right? 2 to the 3rd power, because that means 3 2s. 2 times 2 times 2, right? Now, so we finished with the 2s. We finished with the 2s. Now we're looking at other factors. 8 only had 3 2s, so I'm not checking with 8 for nothing no more, right? Now we go to 42. I see a 7. 42 has 1 7, right? How many 7s does 8 have? None. I'm going to just put a 0 up here, right? How many 7s does 84 have? It also has 1. So again, the question becomes, what is the maximum amount of 7s you see in any of these prime factorizations? That is the key question you need to keep asking yourself when you do this process. What's the max? What's the maximum amount of 7s you see? What's the maximum amount of 7s you see as you're going through this, as you look at the prime factorizations? I see 0, I see 1, and I see 1. The max is 7. So that means to find our LCM, we need 1 7, because you always take the max, the maximum amount of that term or that number that you see. All right, now we go into the next factor. I see 3. I see 3. 42 has 1 3. 84 has 1 3. 8 has 0 3s. So again, the question, what is the maximum amount of blank? That's what you keep asking yourself when you find the LCM. What is the maximum amount of? What is the maximum amount of? What is the maximum amount of? Right? You keep asking yourself that question. The maximum amount of 3s is 1, because it's 1 in 42 and it's 1 in 84. It's 0 and 8. 1 is bigger than 0. So that means 1 3 is going to be part of our process of finding our LCM. Now we just got to multiply out. 2 to the 3rd power. Only reason I wrote 2 to the 3rd power is because I didn't want to write 2 times 2 times 2. Exponents save space and time and energy. That's the purpose of exponents. It's a lot of symbology in mathematics, right? It's not meant to make life more difficult. It's actually meant to save you space and time and energy, right? We got to start to appreciate a lot of this stuff, but you got to learn what the symbols mean. All right. So 2 to the 3rd is going to be 8, because 2 times 2 is 4. 4 times 2 is 8. That's 3 2s. That's 3 2s. This is not 6. You do not do 2, the base times the exponent. You do not do that. You do not do that under any circumstances, right? Now, there's a coincidence with 2 to the 2nd power, because 2 times 2 is 4, and some people might confuse it and think, oh, well, you're just doing the base times the exponent. No, that's not what's happening there. That's a coincidence that you end up with the same product. All right, so 2 to the 3rd power is 8, not 6. And then you do 8 times 7, and you get 56, right? Now, you get 56. Then you're going to do 56 times 8. Oh, that's a good one. 56 times 8. Let's see if I can do this with mental math. So 56 times 8. If I'm doing 56 times 8, this is how I'm doing it. Check me out, right? Watch me work. 56, I'm going to break them down into 50 and 6. 50 and 6. I'm going to do 50 times 8, then I'm going to do 6 times 8. 50 times 8 is just 5 times 8 with an extra 0. 5 times 8 with an extra 0. 50 times 8 is 400. 8 $50 bills is $400. 8 $50 bills is $400. So 50 times 8 is 400. And then 6 times 8 is 48. 48. So you do 400 plus 48, put them together, 448. That's your LCM. Game over. 448. All right. So 448. That's what we got. 448. That's the LCM of 8, 42, and 84. Now, what does that mean, though? The LCM, what does it mean? So I showed you the steps to get it, but conceptually, what does that mean? That means that 448 is the smallest number where all three of these numbers can meet up at by multiplying themselves by different whole numbers. Different whole numbers. So imagine like 8, 42, and 84 was people, right? Imagine they were people, right? So if they're people, they're like, okay, let's meet up somewhere. Let's link up. Where's the meetup spot? And they trying to decide where they're gonna meet at. Like, there's certain places that's convenient for only one person. There's certain places that's convenient for two of the people, but there's certain places that's convenient for these two people. But in order to find the place that's convenient for all three people for us to meet up, it's the number 448, because 448 is the smallest number that 8 can multiply into, 42 can multiply into, and 84 can multiply into by multiplying them by a whole number, right? 8 can go to 400, but 42 can't. There's no whole number you can multiply 42 by to get to 400. There's no whole number you can multiply 84 by to get to 400. It don't exist in the real number system. It don't exist. All right. 448 is that meetup spot. So when you think of an LCM, think of a meetup spot, like a meetup spot that's convenient for everybody. All right. And you got to do the mathematics to figure out, like, okay, boom, like, what's that number going to be, or what's that meetup spot going to be? All right. That's basically all that's happening. All right. So again, another method of finding the LCM. I've done other videos with using prime factorization where I set up a table and everything. And that's cool too. But it's another way. This is another way to do it, though. It's another way to do it. You just got to keep track of your information. Just count up. Remember that question. What is the maximum amount of blank that I see out of these three prime factorizations? What is the maximum amount of this number? What is the maximum amount of this number? What is the maximum amount of this number? And then you take those numbers, put them together. We had 3 2s. We had 1 7 and 1 8. Multiply them together to get your LCM. All right. Stay locked in. See you on the next video.